Warm greetings. Welcome for online video session on software engineering. Myself Jagadish, Associate Professor, Department of Computer Science and Engineering, Canara Engineering College, Bandpur. In the last video session, we have seen about object-oriented designs. In the object-oriented design, we have seen the various examples on the weather station, and we have seen the several things that has to be taken care in the object-oriented design. One is to understand the context as well as external interaction with the system, and second one is design system architecture, and third one is identifying the principal objects in the system. Fourth one is developing a design models, and fifth one is specifying the interfaces. So now we have seen about the context and external interaction as well as architecture of the system design and the principal objects in the system. So in this online video session we see the design models and the specific interfaces. So in the context the system interaction, we have seen the examples on the weather station as well as weather station use cases, and architectural design also we have seen the weather station various components like fault manager, configuration manager, power manager, communication, data collections, instruments, such type of, and each components we have divided into subcomponents. The two separate architecture will be there for each system, and in that we have seen the receiver, weather data, and transmitters, such type of there is architecture for the data collection. And we have seen the class diagram for the weather station. Now we come across on the design models. Design model shows the objects and object classes. Objects and object classes. So it means you come across the classes is nothing but it consisting of a three fields in the rectangular boxes, or class name, and defining attributes and the methods, such type of the classes. So object classes and objects and relation between these entities. We have both, there is one is static model and dynamic model. So what static model describes? It describes the static structure of the system in terms of the object classes and relationship. It describes the static structures of the system in terms of object classes as well as relationship. Dynamic model describes the dynamic relationship between the objects. So static models, you can take it an example in the how we going to define the static models. It looks like a class diagrams, whereas dynamic models it looks like a sequence diagram where it triggers whenever any events occurs dynamically, how it going to triggers, so that we can see it in the sequence diagram. So examples of design of models, we can see the subsystem models that show logical grouping of objects into the coherent subsystems. Sequence model that shows the sequences of object interactions. State machine models that show how individual object changes their states in response to the events. Other models includes use case models, aggregation models, and generalization models. These are some of the few examples we can see in the design models. Subsystem models, it shows the system, it shows the design, how it is organized into logically related group of objects. So UML shows they're using a packages where it encapsulates the construct. This is a logical model. The actual organization of objects in the systems may be different. Sequence model. So sequence model shows the sequences of object interaction that take places. Usually we have seen the examples of the patient health care system, how the patient, how the receptionist, if you, she or he wants to see the patient database, from he has to ask a permission in if the receptionist is a correct user, then replace the bag to the receptionist to view the record, otherwise it gives a error. So such type of the sequence model we have seen. So here we have a sequence diagram for the weather station. Objects are arranged horizontally across the top and come across C. Usually what we have seen the first model, so some of the concepts are all repeated once again in this model also, but with the different diagrams. Objects are arranged horizontally across the top. Time is represented vertically, so models are read top to bottom. Time is represented vertically. Interactions are represented by labeled arrows. Different styles of arrows represents different types of interaction. A thin rectangle in an object is defined as a lifeline. Lifeline is being thin rectangle in an object, represents the time when the object is controlling the object in the system. So once again I explain, give a brief description about sequence model. Objects are arranged horizontally. You can see the top, what we have designed in the rectangular boxes are all objects, and time is represented vertically. So vertical box represents the time, and interactions are represented by labeled arrows. Different styles of arrows are used in an interaction. A thin rectangle in an object represents the lifeline when the object is controlling objects in the system. So you can see this is a diagram of a sequence diagram. So this is, we call it as a, or there is objects. So satellite communication, weather station, communication link, weather data, and this is this also an object, and you can see the thin rectangular boxes represents the lifeline. And see here, so what actually in this sequence diagram it sees the describing the data collection of the sequence, there is data collection of the weather station. So you can see there is a description. First one is satellite communication. Is an object receives a request from the weather information system to collect the weather report from the weather station. To collect the weather report from the weather station, this is a weather data, and it acknowledges the receipt of the request. And stick arrow is there, no? Stick arrow arrowhead on the sent message indicates the external system does not wait for the reply, but can carry on with the other processing. So this is what represents the there is a task request, and it gives a acknowledgement. It won't wait till the weather data, so weather station gives the acknowledgement. So this is what the sequence diagram of the satellite communication requesting a services, that is the weather information system requesting services from the weather data. So satellite communication, it sends, that is a weather information system requests services to send a report, and the satellite communication sends a message to the weather station. Satellite communication sends a there is a message to the weather station via satellite link, and it creates a summary of the weather data. It creates a summary of the weather data. Again, the stick arrow indicates that satellite communication does not suspend itself waiting for the reply. It sends a acknowledgement to the satellite communication, and weather station sends a message to the communication link. Once again, weather station sends a message to the communication link, the communication link object, to summarize the weather data. To summarize the weather data, that is, weather station sends a link to the communication link. In case there is square half arrow, square, that is style of arrow indicates that the instance of the weather station object class and waits for the reply. It waits for the reply from the weather data. Okay, it's a wait for the reply. See here, it sends the acknowledgement immediately, but it waits here till it sends a reply from the weather data. Then communication link calls the summarize method in the object, and weather data waits for a reply. Weather data, it waits for the reply till it gets a summarized data. So weather data summarize is computed. It's computed here, and it sends return to the weather station via communication link object. It sends the weather data to the communication link object. And see the response time from weather data to the communication link, and see the response time differences here. You can see the differences. The arrow ends here and the arrow starts at least something one fraction of second. You can see the differences here, and it sends a reply to here. And see the weather station waits till the communication link sends a reply from the weather state data. You can see the differences here. So this you can see why it is ended only at this point of time, because it works only this minute of time, so remaining it will be idle here also. So whereas here, because it waits till the all the objects response has to be received by the satellite communication, so the timeline is active till the end of the till it gets the data. So once it gets the data, communication links gets the data from the weather data, it will send a reply to the weather station. So weather station then calls the satellite communication. It calls the weather communication, sends the data back to the satellite communication. So it sends a data to the satellite communication object, summarize the data to the weather information system through the satellite communication system. So once it receives, the satellite communication receives the data from the weather station, it sends an immediate acknowledgement that it received. So once the satellite communication receives the data from the weather station, it reply back to the weather information system, and once it is the data, actual data receives, you can see the black arrow here. So it's that is report has been received, and as per as requirement of the customer, that is what to say, from weather station, it receives a acknowledgement to the satellite communication. This is what actually the sequence diagram for the weather station. And you can see here, these are all there is a thick, this should be a thick dark arrow marker. Okay, this should be thick dark arrow, that is thick arrow, that is arrow that is indicate that the external system does not wait for the replay, but an arrow will carry on with the other processing. Okay, this is a request always should be in the thick arrow, whereas acknowledgement should be in the that is stick arrow head. Okay, this is what actually. And coming to the state diagram of the next, state diagrams are used to show how the object responds to the different service requests, and how the state transaction triggered by the request. State diagrams are useful high level models of a systems. State diagrams are useful for high level models of a system or an object. So when where object there is models cannot be understand by the developer, that time state diagrams helps a lot for a better understanding. And you do not usually need a state diagram for all the objects in the system, but many of the objects in the systems are relatively simple, and state model adds unnecessary details to the design. So you can see the state diagram as well as this diagram is also very important in the examination. They can ask, write a state diagram for weather station. They can ask for the 8 marks. So in this you can see that if the system state is shut down, then it can respond to the restart. It can respond to the restart, or it can respond to reconfiguration. So if the system gets shut down, it can ask for the restart, or it can ask for the reconfiguration of the messages, or power save, both reconfiguration as well as power save. The unlabeled arrow is there with a black unlabeled arrow with a black ball indicates that the shutdown state is initial state. Shutdown state is the initial state of the state diagram. Okay, a restart message causes a transition to a normal operation. Restart message causes the transition to normal operation. Both the power save and reconfigure messages causes a transition to a state in which the system reconfiguration or reconfigures itself. Okay, and in the running state is there in the running state, the system expects the further message. Further message, it may be from collecting or from transmitting or from the configuration. Okay, in a report whether message is received, with report whether message is received, the system moves to the summarizing the state. Okay, when running report whether message is received, the system moves to the summarizing the state. When the summary is completed, the system moves to the transmitting state. Whether the information is transmitting to the remote system, then it returns to the running state. Okay, so when the transmission is completed, the transmission is done, then it moves once again to the running state. If a report status message is received, if the report status message is received, the system moves to the testing state. Then from the testing state, the transmission, then it moves to the transmitting state once the test is completed. Before returning to the running state, after completion of the testing, it moves to testing completed, it moves to the transmitting state. So in the transmitting state, once again transmission is done, then it moves to the running. If a signal from the clock is received, if the system, there is a signal is received, the clock is received, the system moves to the collecting state. The system moves to the collecting state. Then when it collects the data from the instruments, so each instrument is instructed in turn to collect its data from the associated sensor. You can see the clock. Once it is clock is received, the system moves to the collecting state, where it collects the data from the instruments. Each instrument is instructed in return to collect its data from the associated sensor. If a remote control message is received, the system moves to the control state, remote control state, in which it responds to the different set of messages from remote control. So these are not shown in this diagram, but state diagrams are useful for high level models of the system, okay, and objects, operations, etc. and usually you need a state diagram for all objects in the system. So many of the objects in the systems are something relatively simple and has a unnecessary details to the design. So state diagram is required for only for the high level system. It's not required for the low level, high level system design. Okay, so it unnecessarily creates a mess up with the unrelated information for the developers. So and this state diagram of the weather station is important for the examination point of view also. So make sure and practice this diagram. So practice makes perfect. So practice this diagram. So one is shut down and configure. So that is the initial state. So shutdown operation, that is a restart or configure power save. So running data, that is summarize the report weather, and once it is summarized, it has been transmitted, weather summary completed. Then once it is completed, its move transmission is done and running, and reports status to the testing part, and once the testing is completed, it moves to the transmitting, and it moves to the transmission done to the running state. And as far as clock collecting the information is done, then it moves to the running state. So remote control is moved to the controlled state. So this is what actually, so weather station, how it going to work. So next it is a interface specification. So once you design a model, so once you design a declare an object, once you declare a classes, so next it is a interface is required. Interfaces between the objects, between the models, between the subsystem is required. So object interfaces have to be specified so that the objects and the other components can be designed parallelly. So once object is created, then it is given to the developer, that is even developer, then you mess up with the there is interfaces. So which object, because some of the object has to be called regularly for one or other sake. If the interface is not been designed parallelly, then it may be problem in designing the application. So designers should avoid designing the interface representation, but should hide this in the object itself. Objects may have several interfaces which are viewpoint on the methods provided. The UML use classes diagrams for interface specification, but Java may also be used. So UML class diagrams can also be used for the interfaces, or maybe Java can also be used for object oriented design models. And here you can see the interface diagram is also same. The diagram looks like a class diagram, but in the class diagram we declare the variables in the second row, but whereas in the interface diagram we won't declare a variables, but whereas in the name of a class diagram we will declare as a interface name, as well as in the how there is a declaring a variable will be empty, and the method in the method column we declare the interface functions. Yeah, you can see the example of the interfaces. You can see the interface class, instead of class name you can give interfaces, that is the report and remote control. In the second row we will be empty, and this is what we declare the interfaces functions for the application. So now by this we have completed the there is one is design models as well as interface specification. So next we move on to the design patterns. So design patterns covers there is it is there included in the topic, so we'll cover this also. Yeah, design patterns is a way of reusing, make a sure note of what is design pattern, is a way of reusing the knowledge, abstract knowledge about a problem and its solution. Making reuse pattern, design pattern is a reusing the knowledge of the abstract, that is about a problem and its solution. Pattern is a description of the problem. and its solution. It should be sufficient abstract to be reused in different settings. Pattern descriptions usually make use of the object-oriented characteristics such as inheritance, polymorphism, as well as generalization, multiplicity, etc. So design pattern elements. What are the design patterns elements? Before that, design patterns were derived from the ideas, but forwarded by the Christopher Alexander, who suggested that there were certain common patterns for building a designs that were inherently effectively, and pattern gives a description of the problems and its solution. So solutions may be reused in different settings. Okay, so pattern elements have a name, problem description, solution description, and consequence. So once again I said this question also important for examination. They can ask what are the 4 essential elements of the design patterns that is defined by the gang of 4. Gang of 4 in the sense the 4 person has been joined together to form a design pattern solution. So gang of 4, that has been published a paper, so they've been given a name as a gang of 4. 4 person has been included, have been joined a hand to form a patterns elements. One is name, second one is a problem description, second one is a solution description, and fourth one is a consequences. Okay, and observer pattern. So this is one of the example they have given. Name of the is a observer. Description, it gives a separates the display of the object state from the object itself. And problem description, used when multiple display of states are needed. Solution description is a slides with UML description. Consequences, optimization to enhance the display performance are impractical. Okay, you can see this is what the observer pattern. One, description. So name of the pattern is an observer. See, 4 patterns. The gang of 4. What they are described is pattern name, observer, description, separates the display of the state of an object. This is one example they have given. Just read out. You can see the pattern name, observer, description they have given, and problem description. And the next one is they're going to give the solution description, as well as next last one is consequences. The subject only knows the abstract observer and does not know how details of the concrete classes. So this is what the one example is given. That is not much important, but is important here is the pattern name, description, problem description, solution description, and consequence. The pattern name, this is what is required, important. Okay, and you can see the one that is diagrammatically observer 1. There is a pattern view is, it looks like a that is what pie chart. Okay, and observer 2, it looks like a that is bar chart. Okay, you can see the subject of A, B, C, D is given there. A 40, B 25, C 15, D 20. One observer is it sees in a that is bar chart. Observer 1 will see it in a pie chart. It is depending upon the how the observer will look, and both pattern both are correct, but in their view. So observer 1, observer 2. So pattern, this is one of the pattern been given example. Okay, multiple display. So one answer can be shown in a different way. So this is what one example they are given. Okay, so UML model for the observer pattern. So observer and subjects, these are all the subjects they are declared, and there is a written one subject, concrete subject. This is not much required. You can see this how they have designed inheritance of the subject as well as inheritance of the observer. And there is observer 1, observer 2, and that is for this is for one user. if they have multiple user, so they inheritance the all the others attributes as well as functions from the observer as well as subjects also. If it is one subject, okay. If there is multiple subjects, the inheritance the objects, attributes as well as members of the subject. So design problems. To use patterns in your design, you need to recognize that any design problems you are facing may be associated patterns that can be applied. There are several objects that state of some other objects has changed. Tidy up the interface to a number of related objects that have been often been developed incrementally, set by the Faget pattern. Provided a standard way of accessing the elements in a collection irrespective of how that collection is implemented. Iterator pattern. Allow for possibility of extending the functionality of an existing class at running time. Decorator pattern. So this is what the given the description about the design patterns. So by design patterns can also solve the problems of the programmer. Better always have a meaningful reference to the pattern. Whenever you design a pattern for the problem, it is always give a meaningful reference to the pattern. And second one is a description of the problem. So it is always give a better description of the problem area that explain when the pattern may be applied. So when the pattern can be applied for the solution. And third one is a solution description of the design solution. So it gives a relationship between the object classes, inheritances, polymorphism, etc. A state of the consequence, that is the results of applying the pattern. When what happens when the pattern is applied, what will happen, the results, that is what seen in the design pattern. So this is 4 essential elements of the design pattern that is designed by the defined by the gang of 4. So in the examination they can ask what are the essential elements of the gang of 4. Okay, please make a note on this, and it's a very important question. And in the next class we'll see the remaining parts or remaining topics in the module 3. Thank you.